This is a simple mechanical example of standing waves. I have a piece of wire taped to the cone of a speaker, driven by a signal generator with a sine wave signal, right now set to about 19 or 18 hertz. And as you can see, this wire is definitely vibrating as the cone moves up and down, and it pivots right there at the edge of the speaker frame. The rest of the wire resonates, and you can see the way it's resonating is kind of peculiar. You can see a large vibration here. You can see a fairly large vibration at the very end of the wire, but then right here you find a point that doesn't seem to be vibrating much at all. And we refer to that as a node. And we refer to the maximum vibration points as antinodes. So antinode, node, antinode, and of course you have a node right here where the wire comes to rest against the frame of the speaker. You see standing waves in a variety of phenomena. For example, you could have standing waves in a transmission line with voltage or current signals. As you have signals propagating along the line, then reflecting off the end of the line and coming back. As they constructively and deconstructively interfere, you can form areas of nodes and antinodes where you've got maximum voltage or current or minimum voltage or current. And of course you could see it mechanically in something like this, where you've got a shaking object, but it's shaking in such a way that certain parts of it move more than others. Now this will happen at certain specific frequencies. So right now we're roughly 18 or 19 hertz. If I dial the frequency up, however, and get it closer to 50 hertz, we notice another resonant pattern. Zoom out here a bit. Now this one's more difficult to see. And in fact, the way it appears on the camera is kind of strange. It looks like it's slowly undulating on the camera. In reality, it's vibrating much faster than that, but what you're seeing is the visual effect of the camera's refresh rate mapped onto the actual vibrating frequency of the wire. But again, you see nodes and antinodes. For example, right here is an antinode, a place with maximum vibration. You see the same thing over here as well. But right here is a node. It's hardly moving at all. Again, right here is a node, hardly moving at all. So before we saw a node near the end of the wire, and of course one at the edge of the speaker frame, but now we see a second node here. In other words, with a higher vibrational frequency, we set up a different pattern of standing waves, having more nodes and more antinodes. And you see the same sort of thing with transmission lines too. As you increase the frequency of a signal being sent down a line, and then those signals get reflected back, their constructive and destructive interferences create patterns of standing waves with more nodes and antinodes than you'd have at a lower frequency. So anyway, kind of a cool illustration of standing waves done using very simple equipment. A standard moving coil speaker, a piece of wire taped to that speaker and resting on the edge of the frame, and a signal generator set to a sine wave.